Hello. So for Boilermaker 8, we made a search engine called Inquery that helps students produce CS students explicitly to find professors with similar research areas which they're interested in order to better find research projects. We did this because it's cumbersome to go through pages and pages of research profiles and like professor profiles. It's annoying. It's bad. Okay, a demo of our project. So this is the homepage. Inside of this search bar, you can enter an area of interest, such as, for instance, what if I'm interested in combinatorials? It comes up with a professor whose research interests align with that. Parallel algorithms, graph algorithms, combinatorial scientific computing. So, it works fine with me in this case. In terms of tools that we used,
We use various tools. I'll be talking about some tools that I use, which was specifically Spacey and NLTK, and also Beautiful Soup for the web scraping and parsing of data acquired from professors' bios.
okay. Since this is a web app, we used Flask since it's a really lightweight, really simple to use Python framework for making web apps. Additionally, HTML, CSS, of course, to make styling guides for the web app, and also just to make the templates for the web app. Yeah.
Yeah, the tool that I primarily used was mostly Firebase and Python. Firebase was used to actually store the data that came in from scraping the websites, and then Python was used to both read and write to that database.
So this is an example page of Professor Alex Pothin, and as you can see on the right, that's our Firebase database. So we have a list of professors under prof data, and for each professor, there are various fields such as bio, education, full name, etc. And I created the bio by basically just searching for keywords that could signify research or like interest in certain areas, and then indexing those sentences to create the bio, to create the keywords that would be that would go into the research area category, which would be part of the search engine that would be correlated to user searches to find the appropriate professor that a student was looking for. That was basically just done by keyword analysis, so kind of similar to the bio, looking for important words in the professor's page.
Okay, I worked partly on the front end. I did the bare bones of it and also implemented most of the implementation details for the search algorithm. It's pretty simple. What it does is it takes each of the keywords that Shelley described in the research areas that the professor was interested in. It shortened it to their root word using NLTK. And then I did the same thing with the query and then just checked whether the query was inside of the research area array for each professor. And if that was the case, then I would show the professor as a result. Kind of finicky, but it's useful in the case that we're using it. Moving on, Ryan did most of the heavy implementation details for the front end, so I'm going to let him describe his role right now.
The data retrieved from Firebase is used to render the results page of the website. I use Jinja, which is a templating language for Python, to allow me to display each search result in their own card. Each card contains information such as the professor's name, bio, education, publication titles with links embedded in it, and their website. Using some CSS, the cards are spaced from each other, and hovering over a card makes it pop up a little bit. There's also a back arrow button at the top left corner of the page that takes the user back to the search page